Have you ever stopped to think that the Earth, this planet we walk on every day, might hold secrets greater than any story we've ever heard? Like a book with ripped-out chapters, our planet carries gaps in its history that still leave scientists scratching their heads. Can you imagine what might have disappeared into those giant holes in time, where billions of years seem to have simply vanished without explanation? What if I told you that there's a theory suggesting the Earth was once a ball of ice, almost uninhabitable, which could have changed the fate of all life forms? Or that perhaps the greatest mystery of our existence lies beneath our feet, waiting to be uncovered? Get ready, because you're about to embark on a journey through Earth's desolate and enigmatic past. A thrilling adventure that will stir your curiosity and open new ways to understand the planet. Imagine this: beneath our feet, the Earth hides secrets that challenge even the most dedicated scholars. What seems like a simple rock might actually hold a giant hole in time, a gap that leaves us without an explanation for billions of years in our planet's history. This phenomenon, known as the Great Unconformity, is like an enigma left by nature itself. It hints at entire layers of rocks and sediments that have simply disappeared, as if the Earth itself swept part of its past away, hiding it from us forever. What's fascinating is that this disappearance isn't an isolated detail, nor is it limited to one place. Across the planet, this absence in rock layers repeats itself, almost as if the Earth had an odd, intentional pattern. Think of it like a history book with chapters that have been torn out. Someone reads, for instance, about a civilization, and suddenly the pages skip ahead 1,000 years. And although our geologists and scientists try to rewrite this past, it's a real puzzle. This mystery takes us to the heart of science, where the questions far outnumber the answers. Have you ever stopped to wonder what else the Earth might be hiding? The question that remains, then, is, how exactly did these holes in our geological history come about? By diving into layers of sediments and rocks that record millions of years of changes, we find this gap of up to 1.2 billion years. A true temporal leap in our history. This vacuum raises some of the most fascinating hypotheses and theories, and naturally, opens space for even wilder speculations. What could have been so powerful as to erase an entire stretch of Earth's history? At this point, researchers begin to investigate sediment layers, wondering if this could all be connected to other natural forces or perhaps even to catastrophic climate events. Our planet's history unfolds in layers, and those who look closely at Earth discover a true rock trifle, where each stratum holds secrets of past eras. This stratigraphy works like nature's layered cake, where each slice represents a different period. But there's something curious. Some pieces of this cake are simply missing, as if someone had passed by, taken a bite, and walked off with a piece of history. This leaves a trail of questions and even a bit of discomfort for anyone trying to understand the sequence of events that shaped our planet. Why are some of these layers intact while others seem to have been blown away by the wind? Sedimentation, the process of material accumulating over millennia, should generally follow a logical order. Yet the gaps, or rather, these unconformities in stratigraphy, tell us that something disrupted this sequence. Imagine you're exploring the past in a book, and suddenly you encounter missing chapters. What would you do? The same goes for scientists, who sift through nature for clues about what might have erased these crucial parts of history. Each layer, each sediment that has accumulated over billions of years, brings signs of the Earth at different times. From the atmosphere to the creatures that inhabited the planet, passing through drastic climate changes. But this absence of certain periods in the layers seems to point to major impact events. Could it be a sign of large natural catastrophes? Or perhaps of an erosion process more intense than we could imagine? These questions reveal just how much of our geological history remains a mystery and lead us to question the mechanisms that could have shaped the planet in such profound ways. Erosion is one of those natural processes that, although discrete and silent, can transform the entire planet over billions of years. Imagine water, wind, and ice working as tireless artists, shaping Earth's relief and, little by little, removing pieces of its history. This is how unconformities in rock layers emerge, like giant holes showing the absence of certain parts of the Earth's chronological order. These gaps are like wounds that never healed, revealing that something disrupted the natural sequence of sedimentation one would expect to find. Interestingly, These unconformities can appear in various places on the planet, as if they were clues scattered around for those who know how to look. In deserts, mountains, and at the ocean floor, erosion marks reveal moments when the planet underwent major changes. What's fascinating is that, when looking at these remnants, a geologist might almost feel the touch of nature working persistently over millennia. And of course, this raises an inevitable question. If Earth has managed to erase part of its own history, what other surprises might still await us, buried and forgotten? These interruptions in the sedimentary sequence are not just natural accidents. They indicate events that go beyond the ordinary. Massive floods, earthquakes, glaciations, and even tectonic activity could have been responsible for removing entire rock strata, leaving these gaps. For those venturing into the study of Earth, finding these unconformities is like finding an open door to the unknown, leading us to think about the forces capable of reshaping the planet in almost unimaginable ways. And of course, there are other aspects that make this mystery even more intriguing, which lead directly to the first steps in discovering these geological wounds. Back in the 18th century, visionary geologist James Hutton had the first glimpse of a concept that would forever change our understanding of geological time: unconformities. In a remote part of Scotland, at Siccar Point, he discovered a spot where younger rock layers rested on much older ones, forming a giant time hole. Picture the scene. Hutton, looking at those rocks, realized that the Earth had a history that extended far beyond what people imagined at the time. He understood that nature held secrets that demanded a new way of looking at time. Years later, another geologist, John Wesley Powell, deepened these ideas, expanding the notion of unconformities as he explored the Grand Canyon. Among the vast canyon walls, Powell found a record of rock layers stretching across continents, revealing temporal gaps that could only have been caused by events of unimaginable proportions. When we look at the Grand Canyon today, it's as if each stratum is an open page of the past, where some chapters are missing, ripped away by the planet itself. For Powell, it was as if Earth kept these layers as a grand puzzle for anyone bold enough to explore and decipher. The impact of these discoveries was so profound that even today Hutton and Powell are revered as pioneers of geological time. They taught us that Earth's history is not a continuous book but a collection of fragments, where each discovery brings new questions. If Siccar Point and the Grand Canyon hide giant holes in time, imagine what else might be scattered across the planet, waiting to be revealed. And for every scientist today who delves into these unconformities, Earth seems to whisper an ancient mystery. Can we truly understand its real story? The Snowball Earth theory is one of those ideas that makes you stop and imagine a completely different planet. According to this theory, hundreds of millions of years ago, Earth went through an extreme glaciation, with glaciers covering almost the entire surface. Imagine a nearly all-white, inhospitable Earth, where ice not only dominated the landscape but also shaped its future. During this frozen period, it's possible that glaciers scraped Earth's crust, removing layers of rock and sediment, creating gaps in the planet's history. The interesting thing is that when we think of Earth as a giant ice ball, we understand the power of natural forces. If this theory is correct, these ancient glaciers would be responsible for carving and even removing parts of the crust, which would explain some of the large unconformities we see today. When an entire planet turns into a frozen giant, the erosion caused by ice can be intense, capable of sweeping away millions of years of geological history. This phenomenon would not only have altered the landscape but also created empty spaces in rock records. And what was left when the ice began to melt? As this glacial era came to an end, sediments and minerals eroded by glaciers began to be transported, starting a new cycle of sedimentation. It's as if nature had reset part of its cycle, creating new layers on areas previously scraped by ice. This opens the possibility that many of Earth's secrets are hidden not only by time but by drastic environmental changes. And, of course, these extreme conditions left a curious legacy. By releasing these minerals, the planet may have set the stage for one of the most surprising events in the history of life. After the ice began to melt and the glaciers receded, Earth seemed to be reborn, and with it, an unprecedented explosion of life. This moment became known as the Cambrian explosion, a time when complex life forms began to appear rapidly, filling the oceans with a diversity unseen before. The theory suggests that the melting glaciers after the Snowball Earth phase released essential minerals and nutrients, which, accumulating in the oceans, created ideal conditions for life to thrive. It's as if Earth had prepared a feast for these new creatures. These minerals, once locked in rocks, were now free to be absorbed by the seas, enriching the aquatic environment. Picture it. A primordial soup where the right ingredients started to combine, giving rise to increasingly complex organisms. It's possible that these changes in the marine environment sped up the evolutionary process, like a nudge from nature that made life bloom in unimaginable ways. This period of accelerated development can be compared to a spring for life on Earth, where the oceans became the stage for the emergence of the first multicellular creatures. This phase transformed Earth irreversibly, bringing forth new species and, with them, an ecological variety that would become the foundation for all future life. The connection between melting glaciers and the Cambrian explosion is a window into understanding how the planet can regenerate and create opportunities out of extreme conditions. So, while some look to the past and see only mysteries, others see a grand cycle, where even the giant holes in Earth's history become the prelude to the next era of life. It's the kind of insight that makes us wonder, what other secrets does Earth have in store, ready to be uncovered? Now that you know these hidden mysteries of the Earth, here's the invitation. What will you do with this knowledge? Are we ready to unearth the secrets that shaped our planet? Earth's history is our own, and understanding these gaps in time can help us envision a clearer future. After all, what else is hidden beneath our feet, waiting to be discovered? And what mysteries of nature could help us reveal our own potential? If you feel that curiosity stirring, let it be the spark that drives you to explore more. Subscribe to the channel, turn on notifications, and follow our upcoming content. Let's unravel each enigma together and dive even deeper into the mysteries of our planet.